Now we are going to move to the second and the last session, the identification technologies and systems. And I'd like to hand it over to moderator, Professor Jin Young-moon from Soonchunhyang University. Professor Jin.
Good morning, S colleague, and good afternoon, TTA colleagues. I am Byung-moon Jin, working for Soonchunhyang University in Korea, and I'm a moderator of this second section. Now, I'd like to start the second section of this workshop. The title of this section is The Identification Technology and the System. In this section, we have three speakers, two speakers, and one panel discussion. And in this panel discussion, we have 5 panelists. The first presentation is from EU, the identification technology and the system in Europe, mechanism for privacy assurance and verification. Mr. Scott Cadjoe, the floor is yours.
Professor Jin, before giving floor to Scott, so I think I need to present a introduction of these sessions first.
I'm sorry. First one is the introduction of this section. The presentation will be done by Professor Young Hung-yeol. The floor is yours.
Thank you. Thank you. So my name is Hung-yeol Young. Actually, I am professor of Soonchunhyang University in Korea. And also I am one of the commissioner for our Personal Information Protection Agency in Korea. So I would like to briefly introduce a session regarding the concept of de-identifications and all other frameworks. So de-identifications. So why we need identifications? According to the ISO 28889, the identification process is defined a process to remove association between a set of identifying attributes in the record and then data principles. So there is a need for utilization of the data, and there is also need for protection of the data. So we believe that the identification could be a practical tool that enables using data in big data environment while balancing privacy protection and utilization of data.
지금 화면 공유가 지금 잘려서 나와서 잠시만 네, 한 번만 중지했다가 다시 하겠습니다. 네, 알겠죠? 지금 어떤가요, 감독님? 네.
Thank you. So let me continue. So according to the ISO IEC 29100, 11 privacy frameworks were defined and described, from the collection limitation, data minimization, and privacy compliance, and consent and choices. So I think that the identification techniques may be relevant to the two principles, collection limitation and data minimization. So So this is a key concept of all types of the data. For example, PII is information can be used to identify PII principles. But if we replace a direct identifier in the data set with a pseudonym, we call that data is a pseudomonas data. And then we apply the identification process to the PIA data, resulting in the de-identified data. And then we apply further a de-identification process to the de-identified data. We can end up with a anonymized data. So that is a main concept of the data, some types of data itself. So according to the list documents, so there is a several level degree of the data itself. So right side, starting with a identifying data, and then we use some identification, the identification process which result in a K anonymous data that is defined to the data that can be anonymously linked to several individuals. And then if there is a right side anonymized data, so data that is not related to the individuals. So I think that from the usability of data, so we believe that if we use a identifying data, we can produce some degree of high level usability. But if we use a anonymous data, the degree is lower than the previous one. And according to the ITOT XRAT 1941, there are 4 de-identification stages are defined in these recommendations, starting from the identifying data, and then pseudonymized data, and unlinked pseudonymized data, and also de-identified data. So if you go into the right side, high level of de-identification can be achieved. So that is the stage for the de-identified data. So when the identification process could be applied, so there are many points has been identified in ITOT XRAT 1941. So as I mentioned, the identification technique applied to any data lifecycle process, such as a data release and transport. For example, when data is collected, the data can be identified to become a de-identified data. And then, so I think that there are many life cycle stages. So anytime the identification technique can be applied. And according to the how XRAT 1941, the identification process has been defined as a 4-stage. First stage, preliminary review. So to determine whether a data contains PII. Second stage, apply the identification process. So to remove a identifying attribute from the data set. And then stage 3, adequate assessment is carried out. Is the data set adequate to meet a minimum the identification security levels, so-called a K Anonymity? Yes, in the cases, the identification data can be used to identify data subjects by using a analysis process So that we call that is a de-identification. So that de-identification data should be protected by the organization, by the some security measure, technical measure, and also organization measure. So that is and then according to the ISO IC 2889, so all types of the identification techniques have been defined. Actually, this 20889 was published, I believe, the 2018 or 19. So we can use this type of all types of the identification techniques to conduct the identifications. And then, so as I said, the left side identifying data, and middle side de-identified data. So the identification is process of the association data in the identified data set with the original data principle. So there is some risk, so-called a de-identification. So if we conduct some attacker conduct a de-identification attacks to convert a de-identified data into a de-identified data. So that is a main issues we need to consider. So when this type of the de-identification data can be used, for example, for a testing software applications, and then so for other purpose is for the statistical reporting, and also for research process purpose, for which a researcher perform a novel analysis, and also there is some the identity data needs to be transferred to the individual level to do a statistical to obtain a statistical data. So I think that is a main use cases for utilization of the identified data set. Pseudonymization, I would like to. So according to our role in Korea, Personal Information Protection Act, actually, according to our role, personal data is defined as a information that identify a particular individuals. So that is and then there is some conditions. Whether or not there is a easy of combination shall be determined by reasonably considering the time, cost, and technology, etc. So actually, our role act has been revised, I believe, that early of 2020. So we introduced a concept of the pseudonymized data. Actually, this pseudonymization has been defined as a procedure to process a personal information so that a information cannot identify a particular individual without additional information by deleting in part or replacing in whole or in part such data. I believe that GDPR has some definitions. And we also have some indirect definitions on anonymized data. So that anonymized data is information that no longer identify a certain individual. So that is our roles. And then actually Article 28-2 mentioned a PII controller may process a pseudonymized data without consent of data subject for statistical purpose, scientific research purpose, and archiving purpose in the public interest. And also combining pseudomonas data from different data controller is restricted. But if we use a specialized institute designated by our commissions or head of the other related central administration agencies that conduct a combine of the pseudomonas data from different data controllers. And then I would like to give two use cases how pseudomonized data can be used in Korea. So there is a organization, and then data and subjects can be collected, and then we applied the identification process was pseudomonized process to become a pseudomonized data set. And then data set should be a transfer to the data recipients, also to the data recipient, transfer to the also data nation. And then we has some specialized organizations. So if we combine the roles of the pseudomonized specialized institutes, combines the identification data from organization A and also the identification data from organization B, and then produce a combined pseudomonized data. That is a main two use cases. And so actually PII controller who intend to export the combined data outside the institution that combines the data shall obtain a approval from the head of the specialized institution. That is our regulations. And then since pseudomonization data is not a anonymized data, so we ask each PII controller to impose a security measures. So PII controller shall store additional information needed to restore the original data, and then PII controller who intend to process a pseudomonized data shall keep a record related to the matters. So this is a standard development group working on the identification techniques. Study group 17, question 3, section 7 also has a 1 approved recommendation and 2 work item under development. And then SC27, as I mentioned, ISO IEC 2900 approved recommendation, approved standard, and then the other one is a 2889, which is published in 2018, privacy enhancing data identification technology and classification. And currently, ISO 27559 stage is DIS, privacy enhancing data identification framework is under development. So thank you very much for your time and for your attention.
Thank you, Professor Young. Thank you very much for the detailed information for the identification technology and standard. And we go to second presentation. Second one is from EU, the identification technology and the system in Europe, mechanism for privacy assurance and verification. The presentation will be done by Scott Cadjo, C3L, STC Cyber. Mr. Scott, floor is yours.
Thank you very much, indeed. I'm going to try and minimize the amount of repetition of the previous presentation in this. It should be clear that the methods of achieving de-identification are universal, they're common across the world. So the stuff we're doing in Korea, the stuff we're doing in Europe are broadly very similar. So what I'll talk through is some of the European viewpoints of this, and then how we responded in the European standards environment, particularly in ETSI, to guide our developers in making best use of the understanding we have of the identification and of identity protection, privacy protection. So I'll do that by talking about the EU dimension. I'll talk about some of the standards, and I'll talk a little bit about where we have to go next. That'll be very short because we have to go quite a long way in the future. So if you look first at our regulation, the regulation takes it very clear. The GDPR, which I hope everyone is familiar with, has set a very high benchmark or very high bar to achieve privacy protection and data protection across Europe. And as a result of that, through trade agreements generally across the world. And when we talk about identification, we take great care in the GDPR to ensure that if you are needing to be identified, you take all means reasonable to ensure that that data is able to be protected and allowing anonymization to operate properly. So that if you're properly anonymized, you actually are somewhat cut off from the requirements to comply to some of the more detailed parts of the regulation. So the role generally in Europe has been from the GDPR that anonymization is a good thing. Let's move towards anonymization. And in doing that, you need to make sure that your anonymous data cannot re-identify you. And the very same problems that have just been talked about occur in Europe as well. We then go further. There's a number of other directives we have to be aware of. There's the e-privacy directive, in order that we can refer to anonymization of personal data. That also is covered quite extensively. There's a number of articles, a number of recitals, but again, it very much makes sure that data belonging or used to identify an individual can be anonymized or deleted after provision of the service. So you make sure that users cannot remain persistent in a system after the purpose has been fulfilled. And that's fairly clear in the way that the recitals and articles are written. You then go further and you look at how people have implemented that. And this is where Europe or the EU as a collaboration of 27 nation states have very different approaches to how they've interpreted the GDPR and the regulation. And so some of the areas are slightly different. So although we are all signed up to the GDPR as member states, and I have to say this for the UK as well, we signed up to it before we decided to leave, and we've got an equivalence in the UK's GDPR. But each of our nations across Europe has interpreted data in a slightly different way. So there's no protection under the French law that essentially says that you're impossible to provide full de-identification because re-identification is reasonably possible. And so the views of Germany, Italy, Slovenia, a few others, is that as long as you've done everything that can counter disproportionate effort, then you're satisfied the de-identification role. Some other nation states are not quite so willing to accept that de-identification is impossible or infeasible. You also have to be careful in that when you're declaring your provisions to GDPR, when you're collecting data, you have to be clear that if you're providing anonymization services, that's part of the processing you're providing. So you've got to ensure that processing is known to the consumer, known to the provider of that personal data. So they know that if they give the data, that it will be anonymized in due course, which may give them more confidence using the service, but it's all part of this further processing. And you also have to ensure that the further processing is not, it doesn't conflict with the test on purpose of compatibility of purpose limitation. So you've also got to make sure that anonymization shouldn't be used as an alternative to deletion. And we need to be careful there as well. So GDPR is quite complex. And we've talked already this morning about ISO 29100, which again takes care that the definition we use for personal identifiable information are common globally. They are the same, almost irrespective of where you sit in the world, with very minor cultural differences because of how we have long-term cultural allegiances to our identity. In terms of where we've then gone from standards, our standards responses have been quite wide in terms of the application. Personal information comes from more and more devices. And one of the challenges we've seen for IoT is that you're no longer represented by your name. You're often represented by the devices you use, the way you use networks, your behavior, because that then becomes available to the network. And so we've got to lead our de-identification into more than just deleting my name and address. They have to lead into how are my devices associated with me, and apply de-identification across a much wider set of identifiers. So we've taken a lead in SSTC Cyber for this. We've adopted the core principles, mainly the use limitation and the security safeguards. And then we've tried from TC Cyber to lead out to all the other technical bodies within ETSI, and then from there challenge all the other standards bodies, all the other regulatory bodies, all the other industry bodies to address this core principle. So we've tried to give that guidance and protocols. In other words, making sure that when you're designing a protocol, you make sure that you didn't minimize data from the very start of that protocol. So if your data is not essential to the protocol, discard it from the protocol. If you discard it, it means it's not going to become a problem to you later on. If it's required and is classified as personal identifiable information, how do you minimize that exposure of that data? Do you use it by cryptographic means, encrypt it or hash it? And then you have to also ask, is it required to be persistent? If it's not required to be persistent, discard it. Don't retain it and anonymize it, discard it, because again, that gives you more protection. We're trying to provide those principles across all of our technical bodies in ETSI. But then we also have to be aware that there's a number of views on anonymization. And in Europe, the EU data commissioners in the previous Data Protection Act had an advisory group under Article 29, and they wrote an opinion on the various techniques that achieve anonymization. And we've looked at that fairly carefully in the standards groups. We've then advised designers to make sure that they consult that opinion, because that becomes very important if you fail to do the other measures. If you fail to make sure your data is minimized, if you fail to properly identify data as required and protected by crypto, then we have other measures that take into account. So that addresses how you would deal with things like K Anonymity and all the other capabilities. But what that then leads us to are a set of core requirements. Again, these are in the opinion from the Article 29 group, but they're also embedded into our data protection culture nowadays. So we've got this immunity singling out, immunity linkability, immunity inference, and making sure we build those capabilities or those immunities into our core processing protocols, our core data protection protocols. So we are building out from those requirements for immunity to our protocols as we build them. So from there, we then also look at some of the more complex principles. So again, reinforcing collection limitation principles, data quality principles, making sure that the integrity of data can be assured, the source is assured, that you're not manipulating it out of purpose. You ensure that data quality is tied into the purpose specification. So you're only using the data you need at the time you need for the purpose you need, and making sure the user is aware of that. And that all comes back to a use limitation principle, and then building that with the safeguards principle, the individual participants of the counter principle. All these build together into a set of fairly simple but difficult to implement capabilities and requirements we try and get across our standards. We're using, again, other tools. So we're bringing in our understanding of common criteria, so we can give assurance of our ability to protect data, to build in data. So we looked at how a user is using privacy protection measures before and after the fact, where they can use authenticity, for example, in this picture, to protect against manipulation of identity or to prove your identity. So in order to prove identity, you need to use authentication and then build that through to ensure you can provide services like pseudonymity, or even in that anonymity often requires an initial identifier to be made available, and then build those into the use of the service asset. So you, from the very top of your design, you start off, what is that service or asset used for, or what is, and who's it made by, used by. Then from that, you identify the necessary privacy protection mechanisms. And this is a long, complex task, but we've tried as much as we can in the guidance we give in standards to the best means to approach this, so we can get a much higher raising the bar, so we get much higher security by default, in much the same way as Alex was talking about earlier on, and which GISC is reflected in the IoT guidelines. So in terms of our specific guidance, we've done a lot of work on access control, ensuring we can give guidance on the use of the basic engines, the mandatory access control, discretionary access control, and then specific modes of enabling that, such as role-based access control, attribute-based access control, all to make sure we understand that people get access to the right data at the right time with the absolute certainty of data minimization. And then we also look at identity and how we authenticate that, looking at means of enabling authentication with both identity revealing and identity masking capabilities in order to ensure that the minimal set of data gets across the system, and enhancing that with things like encryption, but also being aware that we should never do this by default. You shouldn't just apply encryption by default. You shouldn't just apply authentication and access control by default, because the first thing you do is identify the purpose. And from purpose, you do the data minimization. We also are looking at applying security controls. So we've taken the universal security controls that have been developed in a number of bodies. We've enhanced those for various forms of effective cyber defense. And in particular, we've looked at one part for privacy enhancement. And then from that, you identify what enterprises should do to ensure the controls are there. So they have privacy impact assessments in place. They have regular review, that they ensure that they are properly postured or properly positioned to supply appropriate controls to the data. So you mitigate privacy risks before they begin in the very business that you're doing, to ensure, again, data minimization, data purpose specification, minimize everything throughout the thing. And then you can see how those data protection controls map to GDPR. So again, if you're wanting to comply to GDPR, you can apply the proper controls, and applying those controls will give you some security or assurance that you're able to comply to the regulation. We're also looking at further means of identity management. And this comes back to the contention we were making earlier on, that as we've developed our use of technology and as we develop IoT devices, a user will not be associated to the network just by their username. They'll be associated to the network by the devices they use, by the behavior those devices inform the network about. So you have to find some way to ensure that those devices can properly be used to identify people. And we've identified some mechanisms to that, to make sure devices are able to declare what kind of device they are and who they're used by. And we've identified 5 core requirements as shown here. The device distinguished by an identifier, the device discoverable by a discovery mechanism, belongs to a class, and the class has an authority, an identifier also has an authority. So all the capabilities we can then start to build into something we're calling an attribute authority tree, which allows us to provide dynamic Merkle tree-like protection systems using cryptography in a newer, more complete way. So as you're developing your system, you identify various forms of credential it has, various forms of attribute your device has, or the person has, and then you can build up your security tree, your identity tree, by means of how you pass through the set of credentials or certain leafs and bring those through. And we've brought that together And there's an example given here that in normal human discourse, you can identify Alice as the woman who's wearing glasses standing next to the window. And if she's the only woman standing next to the window, she's quite easy to identify without needing to know her entire background. You don't need to know an awful lot more than that minimum set of data. And it's the same for an IoT environment. You don't need to know about every window opening sensor. You may just need to know that there's a sensor in a particular room attached to a particular window in a particular location. And we want to get that kind of idea that you don't need large data sets, but minimal data sets that allow you to distinguish one entity from another, even if they're co-located. So in terms of relationship to de-identification, what we're trying to do in this work, and throughout the work we're doing across ETSI and all the standards bodies in ETSI, is very much minimizing the data that can be stored, or minimize the data that is used to uniquely identify the entity and the person using that entity. So IoT devices, the IT device, you want to minimize the ability to link that to an individual, and then addressing those immunities in our data sets and our protocols. So addressing immunities, singling out, and addressing immunity to linkability, and addressing immunity to inference right from the start in our protocols and our data sets. So what we've learned to date and where we're going to go in the future is we're recognizing and trying to prove that identity and identity management is not simple, it's complex. IoT is making that more and more complex because we're building devices as pseudonyms essentially for individuals. As we get more and more data, there's more and more likelihood of that data being used against us. Therefore, the core principles of de-identification, of all the immunities we talked about, of those being in the system, actually minimize that problem set. We recognize then that solutions are possible in the technology, but we can't apply a lot of solutions after the event, after the fact. So we're trying to make sure that we get understanding of these solutions and these core capabilities, these core requirements into the design phase of everything we develop, whether it's intelligent transport, whether it be IoT, whether it be radio devices, human factors devices, anything at all. We want to make sure they understand the consequences of the regulation and the requirements from day one. But ultimately, that means we spend a lot of time on developing those solutions require us to make people understand. And a lot of this comes down to getting people to recognize that when they publish something on the internet or on Facebook or something, that they're making it public, and they need to try and back off from that. So privacy and publishing don't always go hand in hand, and we're trying to get that lessons across. So we are doing a lot of work. We are highly in common with the work that's going on in Korea and other parts of the world, and I think we're moving forward together. So that's all I want to say. Thank you.
Thank you, Mr. Scott Cadjo. Thank you very much for your kind and valuable information for the identification technology and the system in Europe. And next speaker is from Korea. Next speaker is Professor Go Hak-soo. The title will be De-identifying and pseudonymizing personal data in Korea. Professor Go, floor is yours. Professor Go, you are now muted.
I'm sorry.
Yes.
Since we're getting late, I'll try to make my talk short. The two previous speakers already gave excellent explanations as to what is taking place in the EU and also in Korea. So I'll try to overlap. I try to avoid overlap. I'm a legal scholar by training, and I'm not a standard person. So perhaps my talk will have more slightly weighted toward legal or regulatory aspect. Although I look up to standard setting organizations papers sometimes. So my talk will have two parts. First part would be about Korean data protection law, how it has evolved. And the second part will be about healthcare data, because that's one area where a lot of attention has been paid to lately in Korea. So data, in particular in recent years, just because it has become era of big data and machine learning. It's all talk is about data, and there have been a lot of talks and trials to make the data available to the people who need them, while at the same time providing adequate safeguard. So whenever there's a session at National Assembly, Korean legislature, there would be at least one proposal to amend the law. Many times there are many proposals at the same time. And also to talk, there would be an attempt to de-identify the data so that the personal data would no longer be considered personal. Once de-identified, in theory at least, personal data would no longer be personal data, so that personal data protection law wouldn't apply anymore. So that kind of discussions have been going on for quite some time now. And in particular, healthcare data and also financial data got a lot of attention. In Korea, medical service is provided through the whole national service scheme. So National Health Insurance Service, that's a national service organizer, and it also serves as repository of all the requisite healthcare information. So NHIS, National Health Insurance Service, it is really a huge repository of healthcare data. And there have been a lot of discussion as to how the data held by NHIS and also HIRA, Health Information Review Agency, the data held by these agencies, how to make them available while providing adequate safeguard. And the case of financial data, in Korea, there's a scheme called credit register, by which Korea Credit Information Service holds all the financial data from pretty much every individual with transaction history within the Korean financial system. So the Korean Credit Information Service serves as a de facto repository of credit data of virtually every Korean citizen, and how to make this data available while providing safeguard is again in this area gaining a lot of attention. So the discussion really started in earnest in Korea around 2015 or 2015, and the Korean government published the guideline in 2016. So I would say around 2016 was really the start of serious discussions and serious trials. And at the time, what the guideline contained, the key idea contained in the guideline was this K anonymity, the concept of K anonymity. And this concept was already mentioned a few times today. And in actuality, I was involved in some of the projects, and K anonymity was used, and sometimes in addition to K anonymity, L diversity was also applied. So in some cases, two concepts, one K anonymity, second L diversity was applied. And in this case, K oftentimes was set at, say, number 3, or K could be set at 5. If above 10, many people consider that's too much. It wouldn't be much useful if K is set above 10. And in terms of L diversity, L was typically set at 2. Once de-identified that way, some of the data sets could be combined. Well, perhaps many of you would know well, I mean, once K anonymity concept is applied, it's very hard to combine 2 different data sets. And even if you combine 2 different data sets, after applying the concept of K anonymity, combined data set would not really yield much. So much data would be lost. But in any event, data combination was tried under this scheme. And some of the civil society groups, they were adamantly against implementing this scheme. And in Korea, if you violate key terms of Korean data protection law, you could be punished criminally. So some of the NGOs joined together and filed a criminal complaint. You could possibly put into jail just doing this kind of de-identification work. I mean, after a few years investigation, it was turned out by the prosecution's office that what took place didn't really violate Korean data protection law, but there has been a lot of chilling effect. And after this kind of trial and then criminal complaint filed, there have been discussions as to amending the law. And part of the reason was to facilitate data utilization, and at the same time, another practical motivation was to gain adequacy assessment from the EU under the GDPR. In Korea, there are many different laws. I mean, personal information protection law is a general law in data protection area, but there are other laws such as Location Information Act, Credit Information Act. The Credit Information Act contains separate provisions about pseudonymizing and de-identifying the data. Generally, roughly saying very similar to the scheme contained in Personal Information Protection Act. So I'll skip this slide. And in early 2020, last year, the Korean legislature amended the law in data protection area. And one major scheme introduced was pseudonymizing personal data. So it's roughly speaking similar to the provisions contained in the GDPR. So now Personal Information Protection Act serves as main general law in this area, and there's Credit Information Act. And with pseudonymized data, what can you do? You can use pseudonymized personal data for these 3 types of purposes. One is for statistical purposes, the second, scientific research purposes, and the third, archiving in the public interest purposes. I mean, these are basically the same as what's contained in the GDPR. And the the general steps are like this, 4-step approach. I mean, the key steps would be step 2 and step 3. You do pseudonymize the data and review and assess whether that's adequate or not. And you can combine pseudonymized data, and there are expert agencies involved. Only designated expert agency by the government can perform combination work. And in that process, KISA, Korea Internet and Security Agency, serves as a sort of consulting agency, and also provide a key, combination key, typically hashed value of the identifiers. So in that respect, 2 different agencies are involved in the combination work. So this shows the general scheme as to what can happen in the financial sector. And I'll spend a few minutes to discuss what's contained in healthcare industry guideline. There were separate guidelines published in the healthcare sector, and they said you can pseudonymize healthcare data, but at the same time, for some types of data, you should not. And one major area is where human rights are involved, or serious privacy risk is out there, and these are the areas: data about psychiatric diseases, data about sexually transmitted diseases, data about rare diseases, data about age, and data about abuse, physical abuse, or abortion. These types of data, you really should get consent from the data subject. And that practically means you should not do pseudonymization for these types of data. In the guideline, in the healthcare industry, they provide further detailed explanation as to what constitutes scientific research. And one interesting aspect is for conduct pseudonymization, you need to set up data review board and get approval. Data review board has not been out there, but by this guideline, this is a new governance structure that's being implemented. So if there is a safe way to pseudonymize data, you can do it. If there is no safe pseudonymization method, you still need consent. And about how to pseudonymize healthcare data, the guideline illustrate like this. For identifiers, you need to delete or perform generalization. For biometric data, such as heart rate, electrocardiogram, that kind of biometric data, you need no manipulation of the data itself. And for image data, you need to delete identifiers or mask identifiers. You need to delete DICOM header identifying information. And also, for some types of image data, you need to delete surface boundaries. And for, in particular, CT and MRI, that sort of sequential image data, which could possibly be reconstructed through 3D technologies. That kind of data, you need blur surface boundaries. And for unstructured data, you should not pseudonymize, and instead you should get consent. They include free entries, voice, biometric identifier, genetic data. And again, once you pseudonymize healthcare data, you can use for the designated 3 types of purposes, or you can combine pseudonymized data. And possibly you can transfer to a third party, but there are restrictions. And this is a illustrated sequence of how to pseudonymize and use the data for drug research, or how this is another illustrated example as to how to pseudonymize data held by 2 different hospitals and then combine, and then use the combined data for research purpose at one of the hospitals that initiated this pseudonymization process. So I'll stop there and I'll entertain the discussions. Thank you.
Thank you, Professor Ko. Thank you, Professor, for your detailed information and the Korean law situation regarding to the identification in Korea. Thank you very much. And next, we have not so many time, but we have another one is the Q&A and panel discussion. Since we have some time lag, I'd like to ask a short comment from each panelist. And is there any question from panelists for the presentation? Since none, then I'd like to ask short comment from each panelist. You can make a comment for this de-identification technology in the system subject. Scott, please.
Well, I mean, the short comment is that as I think we've pointed out across all three presentations, de-identification is not straightforward. The more technology applied, the more likely de-identification comes. So there are a number of techniques, K Anonymity, L Anonymity, all work, but are all then degraded as you add more and more data sets. And so the guidance we tend to give is much the same as we give for any security technique. It's the best you can do at the time you're doing it, given that we can't predict the future. The very same issue that Alex brought up earlier on in the day, that what we do in security is just give our best assurance. We cannot give absolute guarantees. So for anonymity, for the identification, we cannot give guarantees. We can only give reasonable assurance under certain conditions that we can achieve the job. So I think that's all we can say for that.
새로 들어왔으니까 이종욱.
Okay.
Okay, thank you, Scott. And in this panel, there is a newcomer. There is Professor Lee Jong-hyuk from Sejong University. So I'd like to ask some comment from Professor Lee. Professor Lee.
Hello, this is Jong-hyuk Lee. I'm working with Sejong University in Korea. Thank you for the presentation about the identification. Actually, recently I have some experience about the implementation perspective. Actually, the concept and the importance of the identification is widely well known, and people are very concerned about that. Actually, when they develop some IT solutions, software development, but the problem is that the developer actually, they are very difficult to implement how to make data to be the identification. So I don't know, even if the well-written documentation has been well spread among the country and in Korea, but still the developers are very difficult to make their solution to be align such a guidelines. So do you have any thought about that?
Thank you, Professor Lee.
Yes.
제가 질문지 리스트 그거 하나에서 맨 마지막 보면 그거 하나 좀 이웃집 한번 물어보고.
Now I think we have not so much time. And, I have a question for this section 2. The EU's data adequacy adequacy evaluation process for Korea is in the final stage. Once this adequacy statement assessment is completed, what are the rules or tasks that standard experts in Korea and the EU should pray to support it? I'll repeat again. The EU data adequacy evaluation process for Korea is in the final stage. Once this adequacy assessment is completed, what are the law or tasks that standards expert in Korea and the EU should pray to support it? This is question to EU experts. Mr. Scott, Pedro.
Yeah, I'm just thinking through this. We need to be very careful. The standards organizations are certainly from ETSI's perspective, we do not directly write standards and support regulation. We write standards and support of industry, but industry has to comply to regulations. So in terms of the standards approach, we will determine based on our members and what industry wants to see in what's missing from standards. So the role of EU standards bodies is very much secondhand or at a level of detachment. What we will expect is that the Commission, the EU itself, the data authority, regulators will come back to the standards bodies and identify whether there's additional standardization required. So if we need additional normative standards or even harmonized standards for aspects of ensuring GDPR compliance with international, any changes required that arise from adequacy, then they'll address that back to the standards bodies. So for now, I think the standards bodies will keep a watching brief. We will take a view along with our political masters in the Commission, but we will not directly do anything unless we feel that there's a standards gap between the ability of industry to meet the requirements and what current standards provide. So I think it's probably not the ideal answer, but it's the best we can do. We will not engage in political debate as a standards body. We will engage as a second hand in those debates.
Okay, thank you very much. And because we have some time lag in this workshop, I think we should adjourn this session too. Thank you for all speakers and panelists in this session too. Thanks again. And the session 2 is adjourned. Thank you very much.
Thank you.
Thank you
Thank
for
you.
all. Thank you. Thank you.
Thank you all. Thank you.
Thank you very much.
Thank you.
For wrapping up today's workshop, we're going to have a closing comments from TTA and ETSI.